Alright guys, in this video we're going to be looking at some physical and chemical changes. We have a multiple choice and a short answer question. So here we got a reaction, and a student has two dilute colorless solutions of hydrochloric acid and sodium hydroxide, which are at the same temperature. The students combine the solutions and the reactions represented above occurred. Which of the following results would be evidence that a chemical reaction took place? So we're looking for something with a evidence that chemical reaction actually has occurred. So we got A, the resulting solution is colorless. Well, that doesn't help us. If it results in a colorless solution and it started as a colorless solution, that would indicate nothing really happened. See how it was colorless to begin with? So A doesn't help us. B, the temperature of the reaction mixture increases. That's definitely a possibility because a temperature change is a good indication that a reaction has taken place, whether it gets hotter or colder. That's a temperature change, so could be evidence. The total volume of the mixture is approximately equal to the sum of the initial volumes. That's a true statement, but that's not going to help us if a chemical reaction took place. That's just straight volume change and would be more of a physical change. The resulting solution conducts electricity. That's an interesting one. That would be true, but that's just the dissolution of the salt in a water, and we talked about that one. It's not really actually the conducting electricity going to be evidence that a chemical reaction took place, more as a physical change, if anything. So B is going to be the right answer. The temperature change is a good indication that a chemical reaction has taken place. And this short answer. So the student takes a sample of Z2S, the sulfide of a different metal, Z, and mixes it 100 milliliters of water to form a saturated solution. It also talks about this KSP, and we haven't learned about KSP in our class, so we don't have to really worry about that right now. This question just wants us to write the balanced equation for that change that occurs when solid ZS2 dissolves in water. Now, Z2S, okay, we don't know what the Z is per se. It's just a metal, and they made up the chemical symbol, and that's okay. We do know it's a metal, and we know that the sulfur is a nonmetal. So it's a metal, nonmetal, makes it an ionic compound. So when it's dissolved in water, it's going to break into its ions. So if I want to write a balanced chemical equation, I'm going to go Z2S solid plus water. We could do plus water, or we can just leave it. We know it goes into water, and it's going to form ions. So we're going to have a Z and an S. Now, sulfur has a -2 charge. I know that based on where it is on the periodic table. It's in the same group as oxygen. They both have 6 valence electrons. They're about 2 electrons away from that octet. So it's probably going to form a -2 charge, which means the Z is going to have a +1 charge because it takes 2 of them to form it takes 2 of them to cancel out the -2 charge on the sulfur. So there will be 2 Z's with a +1 charge for every 1 S or sulfide ion to cancel it out. One last thing I'm going to do, I'm going to make sure this is in aqueous form because it has been dissolved in water. So this is a possible balanced equation for this solution. It is balanced. I added that 2 there to make sure it's balanced. And this would be the dissolution of Z2S.